If you're using NX 3D CAD software and want to find interferences between moving parts or create flashy presentations or assembly instructions, you've come to the right place. I'll teach you how to animate in minutes. I've always wondered how these reciprocating saws work, so let's animate one and find out. We'll use Animation Designer inside of NX for this kinematics analysis. Let's start with a new simulation, but first let's hide the saw's case and grips so we can see the internal components. As you may have expected, a motor and some electrical parts and some gears are all inside. We will first need to tell the system what can move, and that's done with rigid groups. A shaft and blade are connected, so I'll group them together. The case and bearings are all fixed, so we need to group them together as well. This weird oscillating part and the bearings race all move together. Then the drive shaft, gear, bearings race, and balls need to be grouped. Once a rigid group is created, notice how they show in color to let me know what I've done so far. Earlier, I set this color option to show this progress. Last is the motor. Since there are a bazillion parts, I could pick them one by one, or to speed things up, I'll just select them from the assembly tree. Looking at all the colored parts, I think I have all the moving parts grouped. Now it's time to tell the system how they can move, and that's what joints are all about. I'll fix the position of the case and bearings. I know the motor must spin, so we'll add a revolute joint between the shaft and the fixed case. Same deal with the drive gear, it needs to rotate about the case as well. The odd oscillating part will rotate about the angled shaft on the main drive part. I know the saw blade moves in and out, so we'll add a slider joint to its shaft and case. Let's see if it works. I'll add a motor to the motor, giving it some speed and a startup acceleration. You know, I have no idea what these values will do, but it's a starting point, right? Oops, I forgot to add a gear coupler to transfer motion from the motor to the drive gear. All I need to do is pick the gear joints and enter the gear ratio. After I hit play, notice how the oscillator moves, but not the saw blade. The transfer of motion is a bit odd. The ball must slide in the shaft cylinder and rotate about the cylinder's axis. I think a point-on curve will work. We want the oscillator to move along the small dotted center line. The trick is to ensure the starting center point is at the correct end of the center line. After playing the animation, the motor drives the gears, which rotates the angled shaft, which oscillates the saw in and out, all on the house that Jack built. Kind of an interesting simulation of the saw, don't you think? Let's measure the blade travel. I'll add a monitor between a fixed face and a moving face. Then we'll plot this on a graph. I'll measure a distance, but I could measure angles or even motor parameters. Once I hit the play button, this graph will plot live data during the simulation. From the graph, you can see the slow ramp up due to the acceleration value that I set. The key here is the stroke length, from about 34 to 58 millimeters. We could probe this graph to get the exact values, but it's about 24 millimeters. Well, that's it. In just a few minutes, we were able to create a pretty realistic simulation of our reciprocating saw. Well, that covers this week's lesson. If you learned something, give me a thumbs up. If you have a tip to share, leave a comment so my subs can learn more. Thanks for watching.